Hi everyone, and welcome to today's Junior Cycle Science Saturday session. So my name is Conor, and I'll be bringing you through a couple of the aspects of the Junior Cycle Science program, which you might be assessed on in the coming weeks. Okay, so if you haven't already, it would be great if you could follow us on social media. So we have Twitter, Instagram, TikTok, Facebook, and our YouTube channel as well. So I suppose the most pressing issue for you at the minute will be your assessment. So there obviously has been a couple of changes to your assessment because of not being in school for prolonged periods over the last 2 years. So you're going to have two different elements in your certification this year. So you're going to have a state certificate, which will just say that you've completed the junior cycle, and that will come from the Department of Education. But you will also have a school report, and this is going to detail your learning achievements during the junior cycle program. So this next line here, which says schools will have autonomy following consultation with the teachers of third year students regarding how this assessment is to be arrived at and the format in which the report is provided. So that's really important because that basically means that every school is going to be different. So what's happening in my school might be completely different to what's happening in your school. So for example, you might have one big final exam at the end of the year. You might have a series of smaller exams, or you might have a grade that's working based off your last 3 years. So maybe a couple of exams now and then CA for the next couple of weeks. So if your teachers haven't already, they will communicate what's happening to you over the next little while. So I'm just going to talk about the standard paper to start off with. So normally in a science paper, we will have 16 questions. We'll have 10 short questions, which are about 150 marks, which is roughly about 42% of the paper. And then 6 long questions, which is 210 marks, and that's about 58% of the paper. Now that's generally for a 2-hour exam. You might have something a little bit different this year. So I know in my own school we're going to have 90-minute exams. I've heard of other schools that are going to have 1-hour exams. You'll know what your situation is in each school. Now, for example, if you're going to be sitting a 1-hour exam, you're not going to be expected to answer 16 questions. You might just be expected to answer 8. So your final paper will reflect how long your exam is going to be. So a couple of general tips for the paper then. Use the space provided for your questions. So there will be space to answer. You won't need any additional paper whatsoever. And if you do need extra space, if one of your answers was a little bit longer than you anticipated, there will be additional space at the back of the short question section and the long question section as well. So it's really important in science that we're straight to the point, because a lot of the places where we write our answers can be quite short. So straight to the point with our answers, use our keywords and use our definitions which we know when we can. Another thing I would say is do try and fill the space provided with your answer. So if you're given 3 lines of an answer, try and write down everything you know to maximize your chances of getting full marks for that question. And if a question uses data such as a table or a chart or numbers, it's really important that we reference back to those. And we'll see that in a couple of minutes when we're looking at our exam questions. So just for your short answer questions, generally we have to answer them all. That might be a little bit different this year in your own schools. Try and provide examples where you can for the short questions. So great if we know our definitions and our keywords, but do try and relate that to real life examples. Another tip I would have as well would be to read through all the questions before you answer all of them or any of them. And you can put a question mark, an X or a circle around any questions you're a little bit unsure of, and you can come back to those at the end. It just means that you're not wasting time at the questions at the start of the exam, and you can move on, answer the ones you do know, and then come back to the ones you're a little bit unsure of. For timing, I'll come back to timings in a couple of minutes, but generally for short questions, about 5 minutes per question, which will give you about 50 minutes, and then that will leave 1 hour and 10 minutes for the long questions. And then obviously you'll have a bit of time to read back over what you wrote as well. And the most important thing is to practice, practice, practice. So once you start going through the exam papers, you'll start to notice that there's a lot of topics that come up all the time. There's some questions that are very, very similar year on year. So the more practice you do, the better position you're going to be in for the exam. Now for the long questions, there's generally about 6 of them here. 4 of them will be worth 30 marks and 2 of them worth 45 marks. And they're the 2 questions that will be at the very end of the paper. And that will give us a total of 210 marks. So for timings, a general rule, because science is marked in 3s, so everything is usually worth about 3 marks, divide the total amount of marks by 3 and that will give you a rough idea of the time. So for example, in your 30 mark question, divide that by 3, you get 10 minutes. For 45 marks, divide that by 3, that would be 15 minutes. Now that's only a rough estimate. You might find that one of your 30-mark questions might only take you 8 minutes, and you'll have a little bit longer then for the rest of the questions. It's completely up to you. Now for distinction, we need to be achieving 90%, and that's going to be 324 marks out of 360. So in the entirety of the paper, that's only dropping 36 marks. And if we think that everything is going to be marked in 3s, that means we can only afford to get 12 parts of the entire paper incorrect, or we can't get a distinction. So that's really important. If you were to think back, providing examples, filling the space, using your definitions, using your keywords, all of those little tips will maximize your chances of getting a distinction. So today what we're going to do is we're going to be having a look at the digestive system and a little bit of chemical world as well in terms of the periodic table and bonding. So the first session, or the first part of the session, we're going to be describing why we need food. We're going to name the main nutrients that we have in food, and we want to be able to recognize the sources and function of each nutrient. Okay, so for our nutrients, there are 6 main nutrients in food. We have proteins, we have fats, we have carbohydrates, we have water, we have vitamins, and we have minerals. So you're probably looking over here and wondering, well, why do I have an image of a cat down there at the bottom? And the reason for that is because that's actually how I remember what each of the 6 nutrients are. So if you take the first letter of each of the nutrients, so we have P, F, C, W, V, M, I would remember that by Pat's fat cat was very moody. So that's why we have a fat moody cat down here in the bottom right hand corner. So Pat's fat cat was very moody. If you remember that, you will be able to remember your 6 main nutrients. Now each one of these nutrients has a specific function in our body, so there's a specific reason that we need it, and it also has specific sources as well, so different foods that will actually have that nutrient for us. So the first one then will be carbohydrates, and you're probably familiar already with where we can get these carbohydrates, so that will be in things such as potatoes, bread, pasta, rice, and then vegetables will be a source of carbohydrates as well. And the main function of carbohydrates is to provide us with energy, so the ability to do our day-to-day jobs. If we move down to proteins then, good source of protein, so immediately if you think of meat and fish and so on, they will be used for growth and repair of cells and muscles. Okay, so our cells are constantly dividing, they constantly need to grow, constantly need to repair themselves, so that's what proteins will be used for. Fats then, the main source of fats will be things such as meat and oils. They're also really important for our body. So just like carbohydrates, they're a great source of energy. We do need them in lesser amounts than we would say carbohydrates, but really good source of energy. And they're also really good for insulation and protection of our organs. So for vitamins, there's loads of different types of vitamins. So for example, even if you think of vitamin B, there's loads of different derivations of vitamin B as well. So we could be talking up on 100 different types of vitamin. But 2 of the most common that we would have day to day will be vitamin C and vitamin D. So vitamin C will be found in things like citrus fruits, so oranges, lemons, limes, and so on, and also some vegetables as well. And the reason we need vitamin C is for healthy teeth and gums. So if you ever heard stories of pirates before, they would have suffered with a disease called scurvy. And what scurvy is, it's a disease of the gums, so their gums might start to bleed, and then they would start to lose their teeth. So that would happen if we weren't getting enough vitamin C. But a lot of different foods that we would have nowadays would have small amounts of vitamin C in them anyway, so it's not something we would have to worry about. Vitamin D is also a really good vitamin that we can take in. Functions will be keeping bones healthy and strong, and one of the main sources of that would be dairy products. But we can also get small amounts of vitamin C by actually being out in the sunlight as well, so vitamin D can be obtained through that. For minerals, 2 of the main minerals which we would intake most days will be things like calcium and iron. So calcium would be used for keeping our bones and teeth healthy and strong. So milk, cheese, and pretty much all dairy products would be really good sources of calcium. And then the function of iron in our bodies is to produce our red blood cells. And good sources of iron would be red meat and vegetables then as well. And then finally, water. Water is used to regulate our body temperature, but it's also really useful for removing any waste that we might have in our bodies. So obviously a source of water is going to be water, but we can obtain water in other liquids that might have traces of water in it, and then most fruit and veg would also have traces of water in there as well. So if we were just to have a look at this quick activity here, There is specific nutrients we may be able to give to people to help them with different things they might be going through. So if we were to look at this image here, we can see that this person is ill, they're after sneezing. So we might be thinking, okay, well, what could we give them to help them recover as quick as possible? So would it be carbohydrates? Would it be proteins? Would it be vitamins and minerals? Or would it be fats and oils? And truth be told, there would be an argument there that any one of those would be great for the person, because let's say, for example, carbohydrates, they might need more energy. For protein, they might need to repair their cells. But we'd probably be looking there at vitamins and minerals would be the most beneficial for them to make sure that they don't get sick again. The next one here, we've already talked about the pirate, and we can even see there in the diagram that he's missing a tooth or two. So what would we prescribe to that person? Well, we definitely will be looking at vitamins and minerals, because if they can up their intake of vitamin C, well, then they won't actually have any missing teeth in their head. The next image here, we have a polar bear. So if we consider the conditions that the polar bear might be living in, it's going to be really cold, so it's really important that they stay warm all of the time. And we know that the fats and oils right down there at the bottom will be really useful for the polar bear, because it's going to make sure that all their organs are protected, but also going to provide them with that level of insulation that they need to stay warm. And then finally here, we have a picture of a couple of athletes. So again, there could be an argument there for each one of those nutrients that they might need. But if we consider they're playing a match right there now, what might they need on the day of that? Well, they're going to need loads of energy to be able to perform at their highest level. So carbohydrates will be a great source of energy before the match. Protein, again, a really good source of energy, and that will be really useful for their training as well to make them as strong as possible. So you would have seen a common denominator there across the board. Any one of those could be argued for that they may need. It's just making sure that we back up our answer with whatever we say. Okay, so here is an exam question which has come up, and we will be looking at exam questions throughout the session as well. So this one was fully based on the nutrients. So here we have an athlete was encouraged to eat chicken and pasta before training. And we're asked, well, what essential nutrient is abundant in chicken? So if you think back to the slide that we had a couple of minutes ago, we know that there's 6 main nutrients that we have. We have proteins, we have fats, we have carbohydrates, we have water, we have vitamins, and we have minerals. So we have to decide which one of those 6 is in chicken. And the most abundant one, abundant means the most, would be protein. So chicken would be a really, really good source of protein. So that would be our answer for that one. For the next one, what essential nutrient is abundant in pasta? Again, really good source of carbohydrates. They might be told to eat that before training because they're going to need their energy. And that energy is from the carbohydrates. And then finally there we have, it is also important for the athlete to drink fluids due to the loss of water during training. And we have to state one way in which water is lost from the athlete's body. So again, there's a couple of different answers that you would have here, but if you were to consider yourself, if you're ever doing exercise, especially in good weather, after a couple of minutes, what you might notice is you start to sweat. And what that is excess water is going to be leaving our bodies. So one way in which water is lost from the athlete's body, we could simply just say, well, they're going to sweat. So here we have another exam question. And back at the start, you would have heard me talking about when if we're given a bit of data like a table or a chart or a diagram, it's really important that we reference the data that's in the table. So before we even look at the question, I'm going to familiarize myself with the data that I have. So we can see here that we have nutrients in whatever food type this is, and it's the amount of the nutrient in every 100 grams of our food. So we can see that in every 100 grams, we have 1.4 grams of fat, we have 45.6 grams of carbohydrate, and we have protein of 7.3 grams. So I'd be looking at this and I'm seeing, okay, well, carbohydrates is definitely the most, fat is definitely the least, and then protein is somewhere in the middle. So now once I'm familiar with the data, I'm going to have a look at my question over here. So we're told the table shows information on a food label. Name the nutrient that provides most of the energy. And we can see here, well, there's 2 ways to think about it. First of all, we can see that there's 45.6 grams per 100 grams. So that will be one argument for the carbohydrates. But also from our own knowledge of the nutrients, we've seen a couple of minutes ago that carbohydrates are the main source of energy that we get. So we will be saying carbohydrates for that first question there. And the second question is an analysis question, and that's why it was important to look at the data. It says, is this food label taken from bread or fish? Well, we've already seen from the data, there's 45.6 grams per 100 grams of carbohydrates, and then 7.3 grams of protein per 100 grams for the fish. So if we were looking at that and trying to decide, well, is that bread or fish? Well, we definitely probably will be looking at bread, because there's more carbohydrates in bread than there would be in fish. And the protein levels are also quite small. So if this was going to be a food source, we would probably expect both of those numbers to be reversed. So higher in protein and lower in carbohydrates. Okay, so that was the nutrients in food. Following on from that, we're now going to be having a look at this idea of a balanced diet. And we're going to be outlining the proportions associated with a balanced meal. And then the final thing we're going to have a look at is we're going to try and explain how our lifestyle can affect our required nutrition. So for example, different people doing different jobs might need to eat more of different types of food. So the nutrients can kind of be summarized within food groups. So we have things like dairy, we have vegetables, we have fruits, we have grains, and we have protein. And within each one of those, you can see there's loads of different examples there. So for example, within dairy, we have things like milk, we have cheese, we have yogurt, we have smoothies, which obviously would be something that yogurt is in. So any foods that can be made out of milk, cheese and yogurt will be a dairy source. Vegetables, we've loads. We've things like broccoli, peppers, corn, carrots, spinach. We've fruits like strawberries, apples, bananas. Grains, which would be your breads, your cereals, your rices, your potatoes. And then your protein, so any meat source will be great in protein, but then things like eggs, tofu, and beans as well. So we want to make sure that our diet is balanced so that we're not eating too much of any one thing. And a balanced diet is one that's going to contain the right amount of nutrients or the food types that we need to stay healthy. And we can see over here in the diagram that they've roughly proportioned the plate. We can see that there's a lot of fruit and veg there. We have lots of carbohydrates there, so lots of grains. But we have very little things like oils, chocolates, and crisps. And you might have seen a structure that looks like this before, which is the food pyramid. Now this is only a very rough guide, and this is going to change for people, but a rough guide for adults, teenagers, and children over 5 will be to follow the food pyramid. And the general idea of the food pyramid is that you eat most of your food from the bottom, and then you eat less and less as you move up through the levels. So for example, we can see down here that the vegetables, the salads, and the fruits, we would probably be recommended about 5 to 7 servings of those a day. So most of our food should be vegetable, salad, and fruit. The next level above that, so we'd be eating a little bit less of these, but still quite a good amount of them, will be things like cereals, breads, potatoes, pastas, and rice. Towards the middle of the food pyramid then, we would have our dairy products, so milk, cheese, and yogurt, generally about 3 servings a day. Meat, poultry, fish and eggs would be about 2 servings a day. But again, we'll be discussing that in a couple of minutes because some people might have to eat a little bit more than that. And then right at the top of the food pyramid, this is where we're going to be eating less and less. So things like your fats, your spreads and your oils, or any foods and drinks that are high in fat, sugar and salt. We mightn't be eating those every day and just every other day. So I've kind of already alluded to this already, but your lifestyle can affect the number of servings that you need every day. So we would have seen in the food pyramid there in the last slide that we should be taking in mostly fruit and vegetables. And then it probably would shock some people to think that the protein was up towards the top of the food pyramid. And we're recommending only about 2 servings every day. So that could work for some people. But if we were to consider an athlete who's out training probably once or twice a day, they're going to need a lot more protein and a lot more carbohydrates than your average person, because they're going to be training that little bit more, they're going to need more energy, but because they're going to the gym and they're working out their muscles that bit more, their muscles are going to need to repair themselves a lot more, let's say, than us. So their protein intake will be a lot higher than 2 servings a day. If we were to consider then an office worker whose job is to go in and sit at their desk all day working on their computer, they're not going to be moving as much. So they might be following the food pyramid a little bit more accurately than the athlete would. Okay, so that was the rough idea of food. And I suppose the main reason we were looking at food is because one of the biggest systems we have to have a look at as part of junior cycle science is the digestive system. And the digestive system is all to do with breaking down that food. So when we intake that food, how do we actually get the energy from it? So it's not just enough to eat the food by just putting the bread and the pasta and so on into our bodies. We're not just going to automatically get the energy. There has to be a process for us to get that. And that's why the digestive system is needed. So we need food for energy and to be able to grow. And that food is going to be broken down by the digestive system so that it can be absorbed by the blood and carried to all of our cells. So let's say, for example, well, why does it have to go into our blood? Well, if you consider yourself going for a run, the cells in your legs are going to be working that little bit harder. So it's not just enough for that food to rest in your stomach. The energy from that food has to go as far as your legs, maybe even down as far as your feet. And the quickest way for that to happen is for the food to pass through the circulatory system or in the blood, because that goes all around the body. Now, obviously, the food is going to be far too big to go into our bloodstream if it wasn't digested, and that's where the digestive system will come into play. That's going to break down the food for us, and the little particles then that are left over will go into our bloodstream and will be carried to our cells. Now, when we talk about digestion, there's two different types of digestion we can have. We can have physical digestion, but we can also have chemical digestion, and we're going to be going into detail on the two of those. And there's certain parts of the digestive system where physical digestion will take place and other parts where chemical digestion will take place. But they're both just as important as each other, because the main goal of both of those is to make sure we get our energy from food. Now, I suppose the most or the easiest physical digestion that we can think of would be directly in our mouth, and it's the first place that food is going to enter. So if we were to consider taking in food, we have to break that down into smaller pieces. We might take a big mouthful of food, not going to be the easiest to swallow it, so we're going to have to break that down. And the teeth are a really good example of how we can do that. So if we have a look over here at the diagram on the right hand side, we can see that we have 4 different types of teeth, and each of them are specialized in doing specific jobs with our food. So our incisor, for example, we can see there, it's towards the front of our mouth, and that's used for biting and cutting. So we can see that it's quite sharp. When we move over to the canine, that's over towards the corner of our mouth, that's used for grasping and tearing. And that's actually the sharpest tooth that we'll have in our mouth. And you can even see that from the little diagram there. We can see that it's quite sharp. And then down towards the back of our mouth, we have what's called premolars and we have molars. They both do the exact same job. The reason the premolars are called premolars is because they come before the molars. So the molars will be at the back of the mouth. And you probably can see these in your own mouth as well. They're quite flat, they're quite large, and they're used for grinding and crushing any food that comes into our mouth. So all of those teeth will work in tandem to break down the food and make sure we get our energy from it. Now, I've already mentioned this, but teeth can have different shapes depending on their function, and we've already seen the 4 types, but it's incisors, canines, premolars, and molars. And we can see here, this is the dental formula, or where they will be located in our mouth. So directly at the front of your mouth, if you look at the center line of your teeth, we're only going to deal with one half of our mouth. So let's say, for example, if you consider the top half of your mouth, look for your center line, and the first 2 teeth that are right there are what we would call incisors. So those very first 2 teeth are your incisors. The next tooth over is your canine, and you actually only have one of those in every half of your mouth. So let's say in this quarter, in the top half, we have 1 canine. So in the full top half of the mouth, you'll have 2. And then we will have our premolars, and our molars will be right at the back of our mouth. So the difference then between physical and chemical digestion is chemical digestion will actually use chemicals in our bodies to break down the food. And these specific chemicals are called enzymes. So before we even get into the reaction there, I just want you to have a look at the diagram, and we'll try to summarize this in simple words, what's actually happening here. So starch is a form of carbohydrate, it's a complex carb, and we can see here that we have 8 particles all bonded together. So it's quite complex because there's a lot of them bonded together there. But towards the end, when that's broken down, we can see that they're a lot simpler, and that's going to be a lot easier for our bodies to transport around compared to the original structure that we had up here. So it would be ideal if we could break them all down into the smaller structures like this. And that is possible using what we call enzymes. So the enzyme that we have here is called amylase. And a little tip that we would have here is that anything ending in ASE is generally an enzyme. So how I would remember this, and I've actually highlighted the first letter of each one of them, I just remember SAM. So starch is acted on by amylase to produce maltose. And maltose is a type of sugar, so that's what's actually going to be put into our bloodstream, transported around our body, and then that's what will give the energy to all of our cells that need it. So if you remember SAM, that's an example of chemical digestion. Starch will be acted on by amylase to produce maltose. Okay, so digestion is actually a complex procedure. There's 5 stages involved in digestion, and the very first stage within digestion will be what we call ingestion. So before the food can even actually be broken down, we actually have to take the food into our bodies. And the one place that we do that is in our mouth. So if you're ever asked to describe what ingestion is, quite simply, it's just taking food into your mouth. So after that happens, digestion actually happens quite quickly, because if you consider where the food goes in, it's directly into your mouth. Chemical digestion will already be happening there because amylase is present in your mouth. But physical digestion is also going to be happening in your mouth straight away as well with your teeth. So digestion will start the breakdown of the food. Now, once that food is broken down, it will obviously be digested a little bit more in the stomach. We have to absorb everything we need from that food. So the digested food is taken into the bloodstream and it's brought to all of our cells. Okay, so anything we need is going to be absorbed into our bloodstream. Anything that's left over, we'll come back to in a minute. So this word here that we have, assimilation, it might be a new word for a couple of people, but this is where the digested molecules are used by the cells to provide energy. So anything that's taken into the bloodstream, sent to the cells, that's going to be used up to make sure our bodies can do whatever it is they're supposed to be doing. And then obviously there's going to be some bits that are left over. We might need to use everything that we've taken into our bodies. So if there was anything that was digested and not used up by our cells, well then we're just going to have to remove that. And that's called egestion. So that's the removal of undigested waste from our bodies. So that's the idea of digestion. I suppose the next part now is going to be to look at the main structures of the digestive system. And this is actually a really common exam question that comes up in some shape or form pretty much every year. So what do we need to be able to do? Well, we need to be able to list the main structures of the digestive system, so be able to name them, identify them, but we also need to be able to describe the functions of each part of the digestive system. So for example, what does the mouth do? What does the stomach do? And so on. And we'll go through those now. So if we have a look here, we can see that this is a rough overview of the digestive system. So you might need to know absolutely everything that's there, but it's good to know most of the structures. So we can see here in the top left-hand corner, the first place food is going to go in is to our mouth. Our food pipe is our esophagus, so that's where the food travels to after we take it in, down to our stomach. And we can see here the kind of pink J-shaped bag that we have here towards the center, that's our stomach. We'll be talking about that in more detail in a couple of minutes. We have this large structure towards the top, which is called our liver. And then as we move further down, we have things like our large intestine, we have our small intestine, we have our rectum, and we have our anus. And that's where egestion will occur. And that was one of the stages of nutrition, which we had a couple of minutes ago. Okay, so we've already kind of talked about this already, but it's good just to recap. So the first place that food comes in and the first place where digestion occurs is in our mouth. So food is taken in, and what is the function of the mouth? Well, it's to break down the food. So our teeth will physically digest the food, but we can also chemically digest the food, because if you remember back, SAM, starch, is going to be acted on by amylase to produce maltose. So there's two types of digestion that happens in the mouth. We've physical and we've chemical. And that has actually come up as an exam question before to distinguish between the two types of digestion in the mouth. So it's good to remember that. So once we have taken the food into our mouth, we have to get it down to our stomach, because that's where a good bit more digestion is going to occur, and that's actually where it's going to enter after there into our bloodstream. So the food is going to move down through a structure we call the oesophagus. So it's also known as your food pipe. And food is moved through the esophagus by a process called peristalsis. And if you have a look at the diagram over here on the right hand side, we can see the food is passing down through it. It's kind of the yellow structure that we have there. But just above that, we can see that the esophagus is kind of cleaved in. It's got a little bit narrower. And that happens automatically in our bodies. It's happening all the time when we eat. That's called peristalsis. So it's kind of like a wave. If you could imagine that it's getting closer in the whole way down, it's pushing the food the whole way down to your stomach. So gravity obviously is going to have an effect. If you're eating food, gravity will pull it down as well. But peristalsis is one of the main functions or one of the main processes that will bring that food down to your stomach. So once the food actually gets to the stomach, physical and chemical digestion actually happens here as well, just like in the mouth. So we obviously don't have teeth in our stomach, so the physical digestion is going to be a little bit different. But the stomach can actually move. So it's kind of like wave-like, exactly like the esophagus. It can break it down by moving the food around. So that's what we call churning. And we also have chemical digestion there as well. So hydrochloric acid is a really strong acid. You might have used it in a couple of experiments in school. And that's actually present in your stomach. and that's there to chemically digest the food so we can get the important nutrients from it. So you're probably wondering as well, how do we not have holes in our stomach if we're going to have something as strong as hydrochloric acid there? And the answer is that the lining of your stomach will actually replace itself every other day, or every so often. So it replaces itself a lot quicker than other cells would in your body to make sure that everything would stay there. So again, we have two types of digestion there. We have physical digestion, but we also have chemical digestion in our stomach as well. Okay, so after the stomach, the food will enter what we call the small intestine. And a lot of students get mixed up between the small intestine and the large intestine. So if we look at the diagram, first of all, just to locate where it is, the small intestine is the one that's towards the inside, and the large intestine will be the one that kind of goes around on the outside. So what happens there? Well, the food is going to enter the small intestine. It's going to have to pass through this pretty much maze the whole way along the small intestine. And it's really important that it does have to pass through all of that, because that's where the nutrients are going to be absorbed. So if we were to stretch that out, it could be meters in length, and that's really important because it gives the small intestine as much chance as possible to absorb as many nutrients as it can. So if it doesn't do it right at the start, well, it has loads of the small intestine left to get as many nutrients absorbed as possible. And then our large intestine, once it's after exiting from the small intestine, will go into our large intestine, and this is where the water is going to be reabsorbed. So pretty much at this stage, all the good nutrients have been taken from the food, and anything that's still passing through, we don't really need anymore. So it's eventually going to be passed through the rectum and the anus and out of our body. So what do we have to do before that happens? Well, there's still something useful in water left for the large intestine. So our bodies will try and reabsorb as much water as it needs, or as much water as possible, before any waste is got rid of. So there's a couple of side structures that we have in the digestive system that help out with digestion as well. So the liver in particular will produce this substance called bile, and that's used to break down or emulsify fats. Okay, so the bile will really help with breaking down any fats that enter our body. And the pancreas will be producing enzymes to help digest food, so that will be its main structure. So again, just as I said a couple of minutes ago, anything that we don't need has to be passed out of our body. So let's say, for example, we've taken the nutrients, we've taken the water, everything else has to go. And that's where the rectum and the anus will come in use. So any waste will be just removed from our body. So at this point here, it'll be useful to have a look at an exam question. So before I even look at the question I was asked, I just want you to pay attention to the top right hand corner where we have the parts of the marks. So we can see that this was one of the short questions. It's worth 15 marks. So a rough idea of time that we would have here, divide that by 3, we're going to get 5 minutes. So roughly about 5 minutes to spend on this question. And you can see, even glancing at it, it probably won't take us 5 minutes to answer the whole thing, which is fine because we can use that leftover time to read over exam paper at the end, or maybe go back to questions we were a little bit unsure of if we'd circle them towards the start of the exam. Okay, so the first part of the question here, we have to label the parts of the alimentary canal or the digestive system. So just be aware of that sometimes it might have a slightly different name. Okay, so part A, if we have a look here, well, where is it located? Well, it's located just above the stomach, but it's going to be obviously after the mouth. So if you can consider, well, what structure was that? Well, we can see it's a long, narrow tube, so that there would be our oesophagus. So the answer for A will be oesophagus. For part B, well, we know that the stomach is going to be a J-shaped bag, and we can see it's roughly J-shaped. So part B, quite simply, is just the stomach. So we could write that in for that answer. Now, part C and D, this is where students sometimes get mixed up because they're unsure of which one is the large intestine and which one is the small intestine. And it's actually labelled pretty well in the diagram there. If you look at D compared to C, D looks an awful lot thicker. So C will be the small intestine because it's that little bit smaller, and D will be our large intestine. And then the final piece, and we actually didn't look at this earlier on, but this little structure that's protruding down here, that's where your appendix is located. So we don't actually really have a function for the appendix in our bodies, but that's where that would be. Okay, so thinking back then, food questions are going to be located within the digestive system all of the time. So we had a question here asking us, what is digestion? So what does digestion actually do for our bodies? Well, digestion is the breakdown of food to provide us with energy. Okay, so the breakdown of food. And in the final part of the question there, we were asked to identify one location in the human digestive system or alimentary canal where physical digestion will occur. Okay, so we should forget about chemical digestion here. We can only focus on physical digestion. And there's a couple of things that you can mention there. So for example, I'll give you two. The mouth, physical digestion is definitely going to happen there because we have our teeth. Physical digestion will also happen in the stomach with the churning that happens there. Okay, so we have another example here, very, very similar to the last one. If we look at the marks here, we can see that it was 21 marks. So this was on the old course when the marks were slightly different. So this would be roughly 7 minutes now for this question. But in the table, we have to write the letter A beside the name of the part labelled A. So let's have a look. Well, there's the letter A on the right hand side. The arrow is going the whole way across, and I can see that what it's pointing to is kind of like a J shape. So is that going to be the esophagus? Is it going to be the stomach? Or is it going to be the small intestine? And we've already seen this. Well, A is going to be the stomach. So we would write the letter A beside the word stomach there. For part B, if we look at where it's located again, it's after the mouth, but before the stomach. So our food is going to have to move the whole way down there. We're going to use process of elimination. It can only be esophagus or the small intestine. We definitely know it's not the small intestine, which means that it has to be the esophagus. So we would write the letter B beside esophagus. And then for part C, well, by process of elimination, again, we've already used esophagus, we've already used stomach, so the only one that's left over will be our small intestine. And just to come back to that question there as well, I'd mentioned at the start of the session there that if you were unsure of a question, to make a guess. And that's especially true for a question like this, where you're basically given options for the answer. So you mightn't have a clue of a question like that, but you know that the answers have to be A, B, or C. So if you're absolutely unsure, just make a guess. If you leave it blank, you're guaranteed to get no marks, whereas if you make a guess and put some of the letters in there, you might get something. Okay, so one function of the stomach, well, it can physically digest the food, or it can chemically digest the food using hydrochloric acid, so it's going to break down our food that little bit more. And in the next one, we actually have to examine the teeth. So let's have a look. The tooth is right at the back of the mouth. So if we remember, the flat teeth at the back are either the premolars or the molars. But if you focus on the word pre, they come before the molars, which means that the one there right at the back will have to be our molar. And what's the function of that tooth? Well, that's for grinding and for crushing. Okay, so it's going to grind and crush any food that comes into our mouth. Okay, so that was the digestive system. It was a brief overview of that. I suppose those two exam questions that we had there at the end will be your standard typical question that will come up in the digestive system. So it's things like labeling the digestive system, given the functions of the parts of the digestive system, but then also being able to examine food sources as well, which we looked at a couple of minutes ago. So that's the digestive system pretty much wrapped up. Now what we're going to do is we're actually going to do a little bit of chemistry. Another question that comes up an awful lot is to do with the periodic table and looking at bonding and looking at atoms within that as well. So what we want to do now is we want to define what is meant by bonding, we want to look at chemical formulae, and we want to look at this keyword for today, which is valency. And then using that, we want to be able to predict the number of atoms that we have in bonds. Okay, so chemical bonds are happening all the time. We want to know how that happens and how we can figure out how they work. So before we get into that, I'm just going to do a quick recap of the atom. So you've probably heard of most of this before, but our atom is made up of 3 different subatomic particles. So we have protons, we have neutrons, and we have electrons. So they're all located in different places. So the protons and the neutrons are both located in the nucleus, which is at the center of the atom. And then the electrons are always found orbiting the nucleus. So you might have learned different words for where they're located. So you might have had rings, you might have had shells, you might have had electron cloud. It doesn't matter which one of those you use. They all mean the same thing. So the electrons move around or orbit the nucleus, and the protons and the neutrons are going to be found inside the nucleus. So the charges, if you think P for proton, P for positive, protons are positively charged. The neutrons that are along with those are neutral. So N for neutron, N for neutral are neutral. And then our electrons are negatively charged. So sometimes you'll see it symbolized by this. You'll have a +1 for the protons, that means positive. a negative one for the electrons, that's just the negative charge, and then neutral has no charge, so sometimes a 0 will be used to represent that. Now, before we get into bonding, one thing just to keep in mind is that when we draw the structure of the atom, we have our rings, but those rings have a finite amount of electrons that they can hold. So the first ring or the first shell can only hold 2 electrons, and then it's absolutely full. It can hold no more. But every other shell or every other ring after that first one can hold a maximum of 8. Okay, so it could have 1, could have 2, could have 3, it could have 6, it could have 7, but once it hits 8, it has to move to the next ring. So we're going to be getting into a discussion on chemical bonds now in a second, but before we do that, one of the key words I just want to highlight to you is the idea of a compound. So a compound is formed when 2 or more elements chemically combine, and you would have heard of these all of the time. So for example, we can see there in the top right hand corner, H2O. That's a compound because there's 2 elements there chemically combined. The H is for hydrogen, the O is for oxygen. They're chemically combined, they form a new substance called water. You might have heard of CO2 before, so carbon dioxide. Again, that would be carbon, that would be oxygen. They're chemically combined, they form something new. So for that to happen, the atoms of one element must bond with the atoms of another element. And that's what the diagram down here is kind of looking like. So if you see the 2 H's and the O, the line that's used in this diagram shows that they're bonded together. So we have 2 hydrogens and we've 1 oxygen. So what we want to have a look at today is we want to know, well, why is it H2O? Why is it not HO2? Or why is it not H2O2? And we're going to get into a discussion on that in a couple of minutes. But before we do that, that's what we call a chemical formula. So this chemical formula is a way of presenting information about the chemical proportions of atoms in our bond. So we're going to be using combinations of symbols and numbers. And you can see that in the top right hand corner, we have 2 symbols there. We have a H and we have an O, but we also have a number in there as well. So we have the number 2. And all of that combined together is what we would call our chemical formula. Now, with the structure that's really going to help us with this is the periodic table. So the picture I have here on the right hand side is a really simplified version of the periodic table, and we'll look at a more complex one in a couple of minutes. But the reason I have this one here is because that's actually going to give us a major clue as to how these bonds are going to occur. So we're going to be having a discussion about valency. So in this simplified version of the periodic table, I'll bring you to the end slide for a second. We can see here, this is the standard periodic table. So this column here that starts with hydrogen and has lithium underneath it, that's what we would call group 1. Okay, and I'll explain that name in a minute. The second column here, which has B, E, M, G, C, A, and so on, that's what we would call group 2. And we're actually going to ignore the whole middle of the periodic table for a second and go the whole way across here to boron. So it has the symbol B. That's group 3. The column with carbon on it, or C, would be group 4. Nitrogen is group 5. Oxygen is in group 6 the whole way down. Fluorine is group 7. And then our noble gases over here at the end are group 8. So some of you are probably wondering, well, why are they called group 1, group 2, group 3, group 4, and so on? And the reason is that that tells us the amount of electrons it has on its last shell. So if you look at hydrogen, underneath it we have lithium, we have sodium, potassium, rubidium, and so on. Every single one of those in that group has only 1 electron on its outer shell. In group 2, beryllium, magnesium, calcium, strontium, and so on, each one of those has 2 electrons on its outer shell. If we go over here to boron, aluminium, gallium, and so on, they all have 3 on their outer shell. This group will have 4 on its outer shell, 5 on its outer shell, 6, 7, and so on. Okay, so we're going to keep that in mind. Now, to go back to this, when we think of bonds, all of our elements ideally want to have a full outer shell. So over here, this group 8, they don't need anything more. Their outer shell is full. They're happy out. They don't really want to react with anything else. But everything else doesn't have a full outer shell. So they either want to share electrons with another atom, they want to maybe give away their spare electrons, or they want to take electrons to make sure that they have a full outer shell. So let's have a look at that. Well, everything then in the first group, or the first column of the periodic table, they have 1 electron on their outer shell. So is it easier for them to give away their 1 electron, or is it easier for them to find 7 more electrons? Well, it's definitely easier for them to lose their 1 spare electron. So that's why they would have what's called a valency of 1. And valency is how many electrons they need to give away or take to have a full outer shell. So all of these here, hydrogen, lithium, sodium, potassium, rubidium, and cesium, they want to give away that electron ideally. The next column, so the +2, we've beryllium, magnesium, calcium, and so on. They have 2 electrons on their outer shell, so it's easier for them to give away their 2 electrons rather than take or find another 6. And then as we move along the periodic table, these will ideally lose their 3. Doesn't really matter for this one here because it's pretty much the same amount of work to give away their 4 or find another 4. These here have 5 on their outer shell, so it's easier for them to find 3. These will ideally want to find 2, and these ideally will want to find 1. So that's going to be really important for us now when we start to have a look at a couple of examples. So this is how we're going to do it. So this is what I call the cross method or the X method. So I want to bond magnesium and chlorine together. And I have to figure out, well, how many magnesiums am I going to have in that bond and how many chlorines? So the first thing I'm going to do is I'm going to find the element symbols. And these will all be in your periodic or your formula and tables book anyway, so don't worry too much about them if you're not sure of the exact names. But magnesium is Mg, capital M, small g, and chlorine is capital C, small l. So there they are. I want to find out their valency, and that's where we look here on the periodic table. So magnesium is in group 2, so they ideally, or magnesium ideally, wants to give away its 2 electrons. So that's why there's a 2 underneath magnesium. Chlorine, on the other hand, is over towards the right-hand side in the purple column. That's in group 7, so it has 7 electrons on its outer shell. So ideally it wants to find a spare electron. So its valency is 1. So all we have to do then to form our chemical formulae is to swap the numbers. So the 2 is going to move underneath chlorine, and the 1 is going to move underneath magnesium, and we can use that to form our chemical formula. So our chemical formula is going to be Mg, and you can write a little 1 there if you want, but I usually wouldn't bother. So it's going to be MgCl2. Okay, so the 2, we're going to need 2 chlorines. And that makes sense because if magnesium has 2 electrons on its outer shell and chlorine has 7 on its outer shell, well, if we have 2 chlorines, one of the chlorines could take one of the magnesiums and the other will take the other. Okay, so we're going to try this one. We have hydrogen and oxygen. So to do this one, we are going to find the element symbols to start off with. So if we can see here, well, hydrogen is in the top right hand corner and the symbol for that is H. So I'll write that down. Oxygen has the symbol O, so let's find that. Well, that's over there towards the right hand side. And we'll write that down. Now we have to find the valency. Well, hydrogen is in group 1, so it has 1 electron that it wants to give away. Oxygen is in group 6, so it has 6 electrons on its outer shell, so it needs to find 2. All we're going to do now is swap the numbers, so use our X method. The 2 will go with the hydrogen, the 1 will go with the oxygen, and we can form our chemical formula. So for this one we have 2 hydrogens, so H2, and we have 1 oxygen. And again, don't have to write the number 1, just having the 1 letter there is sufficient. So H2O, that's water. So in a water bond, we have 2 hydrogens and 1 oxygen. We'll have a look at our next one here. So we have hydrogen and carbon. So again, write down your symbols. We have H and we have C. Where is hydrogen? Well, it's group 1, so it has a valency of 1. Carbon is here. It has a valency of 4. Form your X. So the 4 is going to go with the hydrogen. The 1 is going to go with your carbon, which means our final formula, we could write it as H4C, but some of you are probably realizing you've seen something similar to this before. That's CH4. So I'll actually just rename that one, and that's methane gas, which you might have covered when you were looking at climate change or global warming. So they're basically the same thing. I'm just going to have it as CH4. So I think we have one more. Yeah, we have magnesium and oxygen here. So find magnesium, that's Mg, which is here in group 2. So the symbol for that is capital M, small g, and oxygen is over here, so that has the symbol O. So let's find our valencies. Well, magnesium is in group 2, so it has a valency of 2. Oxygen has a valency also of 2. So formula X, we'll have 2 and 2, so we can have Mg2 O2. And if we wanted to, we could actually simplify that down to MgO. That would be fine to leave as well. Okay, so here is an exam question which actually came up last year as far as I know. So we're told that aluminium reacts with chlorine to form the compound aluminium chloride. Use the periodic table on page 79 of the Formula and Tables book to predict the ratio of aluminium to chlorine in this compound, and then hence write the chemical formula for aluminium chloride. So we don't have the scaffold there this time to help us figure it out, but I'm going to write down the symbols first of all. So we have aluminium, which is Al, and we have chlorine, which is Cl. So we have to find the valency now of each one of these. So aluminium is here in group 3, so it has a valency of 3. Chlorine is over here in group 7. It has a valency of 1. So we're going to swap our numbers. I won't draw the X this time. So the 1 is going to go with aluminium. The 3 is going to go with chlorine. So the final answer will be Al1. I'm not going to write the 1 in there. Cl3. So you can see this is the periodic table here on the left hand side that you're going to have on the day of your exam. So if you just wanted to memorize or learn off the numbers 1, 2, 3, 4, 3, 2, 1 and put them on the corresponding columns in your periodic table, it will make it a lot easier for you to try and work out the number of bonds that we have in our chemical compounds. So that is pretty much it for today with regards to the chemical bonding. It's a very short topic. There hasn't been that many exam questions on it so far, but if you think back to what I was saying at the start of the session, it still is really important because we can only afford to lose 36 marks in the entire paper if we want to have a distinction, and it's a question like that that might catch us out. So it is really, really straightforward to work it out once you know what you're doing. So just find out the valency of each one of the atoms and then you'll be good to go. So just before we finish up, I just want to highlight this to you. So for anyone joining today, there is actually 20% off the ExamRevision website if you want to sign up to all the Junior Cycle Science resources, and I'll talk you through them in a couple of minutes. But use the code Saturday Session, all capital letters, and that will give you 20% off, but it's only until midnight tonight. So if you want to do that, make sure and get that in early. And then also, if you want to access all of the notes from today, there is a link for a Google form down in the description of the video. So you can see here, this is just a screenshot of the YouTube page. You're obviously all looking at the video right now. So if you just scroll down to the description, there'll be a little form there. Just click on that, input your details, and we will get all the notes out to you as quick as possible. So just one final thing I want to talk to you about. I'm just going to bring you over to the ExamRevision website, which looks like this. So some of you might already have accounts, which is great if you do, but if you don't, you can use the code to sign up. So I'm in Junior Cycle Science here at the minute. This is what you will see when you log into the account. So for example, if I click on video tutorials and I wanted to find what we're doing today, well, that's going to be in biological world, and that's going to be in here in the digestive system. So we can see here that there's 3 different videos you can watch. There's the food, nutrients, balanced diet one, which we had a look at today. We actually already looked at digestion today as well, and the digestive system. So you're able to actually do all of that now. So if you were happy with that material, what you could do is you could click on the quiz here, and you'll see here that there's a number of questions which you can flick through to test your knowledge on the digestive system. And that's the same for every topic. So if I go back in here to science, something we didn't look at today was physical world. So if you were revising and you know that circuits is going to come up on your exam in the next couple of weeks, you can click in there and you can see, well, there's 4 videos there to help you with voltage, current and resistance. You have a quiz that you can answer as well. And another really good feature that's there is you can actually build your own exam. So if you want to start testing yourself with a couple of exam questions, so let's say today we were looking at predicting the ratio of atoms and compounds. There's the question we just looked at. So that's the only question that's come up so far. But if you wanted to test yourself with a couple more digestive system questions, we'll click on that, and you can see here that there's questions there. So that's one we did today from a mock. This was one that came up on the state exam in 2019, and you can flick through and see that there's loads of questions there for you to test yourself, and they're all very similar, which is great as well. So one other feature that you can do as part of that as well, if I just add that question to my paper, we will be able to download the marking scheme, so you can actually assess yourself as you work through it as well. So if you were interested in signing up, there is actually an option to have a free trial as well, so you don't have to pay straight away. So just log on to the website, click on free trial, and you'll get access to a couple of the science resources there for free, and then you'll be able to give it a test run. And if you're interested before the end of today, just don't forget that the code is Saturday Session, all capital letters, and you'll get 20% off. So thanks everybody for coming today. I hope you found it useful. Best of luck with your study over the next couple of weeks, and I'm sure you'll all do great in your exams.